Okay, so that was a SIF feature, and this was the last segment I had for features. And before we move on to the next lecture, if you have any questions, I think we can answer those.
When do you expect to grade the midterm exam?
Yeah, midterm we are working on it, and hopefully I think maybe next few days. I'm not sure. It depends. Means sometimes it takes time. So we are trying our best, but soon I think you will have the grades. But we will provide like the solution to midterm. So maybe if you want to use that to do some self-evaluation, that will also be possible. Okay. So I think I had, yeah, I think I have a quiz for you. Let's quickly do that and then. Okay, I think there's a question. Let's first answer that. So you can see my screen, right? Which says pop quiz. No? Okay, let me try again. How about now? Okay.
Yes,
Great.
we can see.
Great. Thank you for confirming. So question from Anthony. On the slide with example for the scale invariance calculations, is K meant to represent the octave? No, K doesn't represent octave. K is the scale of your filter, right? Let me go to that slide. So octave is actually corresponding to the resolution of your image, right? So let's say you start with 300 cross 300 image, so that will be your first octave, and then you want to reduce it. Let's say you went down to 150 cross 150, that will be the second octave. Then you can go to 65 cross 65, third octave. But within each octave, you have like multiple scales of your filter, and in each octave, you're going from 1K, 2K, 3K, 4K, 5K. Okay, so that K is actually what should be the standard deviation for your Gaussian function when you're computing your Laplacian of Gaussian or difference of Gaussian. Does that answer your question? No, pop quiz is not released yet. Let me first go to the question. So Anthony, that was okay. The constant term was the octave. So you can see the slide, right? So this is one octave. All these heat maps, and this is second octave. And if you perform the same filtering operation on maybe a smaller resolution, you will have a third octave. Okay, so octave just represents, maybe you can say like one scale of your image. And then within this one scale, you're actually having different values of K. And you will do that like for all the octaves. Okay, so K is not like tied to octave. K is tied to like each layer in this octave. So let's say the bottom one will have 1K as Gaussian as your standard deviation. The second will have 2K, this is 3K, 4K, and 5K. Is it clear now? Okay, great. So let me quickly explain the question to you. Okay, so the question is, okay, so the question is from histogram, not histogram. This is from SIFT features. Now, the first step is you detect those key points, right? And let's say your key points, you detect one key point and the patch size was 32 cross 32. Okay, so that's one key point. You have 32 pixels in height and 32 pixels in width. And then each patch will have cells of size 8 cross 8. Okay, so this patch will have multiple cells and each cell has a size of 8 cross 8. And again, this is 8 pixels height, 8 pixels width. Now, what we do is we are computing 8-bin histogram for each cell. Okay. Now the question is, what will be the size of the feature descriptor for this whole patch if we do this? Okay, so I think the time is up. So let me quickly go over this, how I should solve this. So this is your one key point, and it's saying 32 cross 32. So I haven't drawn like all 32, it's too dense, but this is like 8 cross 8, right? Which means you have 4 pixels here. So your cell size will be something like this. So each cell will be 8 cross 8. So the idea is you just count like how many cells you will have in this patch. And for each cell you have 8-bin histogram, you just multiply with that. Okay, so in this case, you can see if 30 cross 32 is the full patch, and this is 8 cross 8 is your cell. You can see 1, 2. So this is 1, this is 2, 3, 4. So you will get like 4 cross 4 cells, which is 16. And then 16 times 8 will be like your feature dimension. Okay. So that will be 128. So that's good. Now let me quickly jump to second lecture. I think hopefully we'll be able to finish this today. This is like yeah, so that was all I had for autoencoders. As I said, I will be pretty quick on this. Any questions you have? Okay, question from here. I don't see lecture 10 file. Oh, I think I didn't post it. Maybe I'm not sure. So I think I might have forgot to post it. I will do that after the lecture. Okay, sorry about that. Then question from Prithvi, just to confirm. In image colorization, we are computing the cost of the output with color version of the input grayscale image. Yes, that's correct. The input is grayscale image, but since you're trying to colorize your images, so output should be colored image. So when you're computing the loss, it should be against the colored image. Okay, so that's correct. All right, good. So any other questions on autoencoders? All right. So if not, then I think we can end it early today. So if you have any questions, just reach out. Let us know. And let's end it here. Thank you. Goodbye.